अनम्यूट हो गया ये। शेयर भी कराना होगा। इसको मिनिमाइज कर दीजिए, मिनिमाइज कर दीजिए किसको। हाँ स्टार्ट कर दीजिए, कोई ज्वाइन करे तब ना, या हम ऐसे ही स्टार्ट करें। ऐसे ही स्टार्ट करें, कोई नहीं ज्वाइन करें। अच्छा, well, what is statistics? Statistics is the science of learning from data. Survival analysis is the tool for studying lifetime data, and reference is survival. What is R? R is a language as well as software for statistical computing. It was developed by Ross Yaka and Robert Gentleman. Introduction, installation of R. R can be installed from internet, and this is the link. Go to the web page https grand.r and dash project.org. Download R according to your operating system. Follow the installation process. Introduction to RStudio. RStudio is an interface PDF समझ रहे हैं क्या? नहीं, PDF ज्यादा बेहतर रहता है पढ़ने में। हाँ हाँ, इसको इसको नहीं और नीचे। So, installation of RStudio. RStudio is an integrated development environment IDE for R. Go to the web page https .co download RStudio dash desktop. Download RStudio according to your operating system. Follow the installation process. Creation of R Markdown file. R Markdown is an R package developed by Aleri et al. It provides an interface between documentation and computation with R. It can be installed by using the command install.packages R Markdown and make sure that your system is connected to internet. This will install R Markdown package. Now it can be downloaded using the command library R Markdown. After this, create an R Markdown file as follows. Go to File, go to New File, go to R Markdown. This will create a file with .rmd extension. An R Markdown consists of three parts. Metadata, this is known as metadata, text and code. Metadata is written between the pairs of three dashes. So this is metadata. Concept of a chunk in R Markdown. देखें कोई आया है कि नहीं? कोई नहीं है. ठीक है, थोड़ी देर लेक्चर दे खत्म कर देंगे. Concept of a chunk. R codes are written in a chunk. A chunk begins with the three backticks followed by the curly braces inside which the first argument is R. A chunk can be labeled by any combination of alphanumeric characters. Packages in R. R language has around 21,000 packages which cover a lot of computational and graphical implementations. For example, for ISWR Delgard 2024 is a package which is an implementation of the book by Delgard 2008, Introductory Statistics with R, published by Springer. Installation of the packages, install package name. To install a package, install that packages and make sure that your system is connected to internet, and then the name of the package ISWR. After installation, one has to use the command for loading the objects with the package. For this purpose, we commonly use library or require command. Library ISWR. To get the help about the package, we use the command help. Help pack is equal to ISWR. To load the data sets available with the package, we use the command data TLC package equal to ISWR. Structure of TLC. So these are the structure. It is a data frame, and age, then sex, then height, and then TLC. Names TLC, these are the column names. Head to see the header part. Head TLC, this is the header part. Tail, from the bottom it is showing. And summary TLC, this is the numeric character. This is the integer. This is numeric, and this is the numeric. These are the references. So this is all about chapter 1. Now to go to chapter, to go to chapter 2, W2. Creation a data vector, the function is C. C. So x is equal to C, 5, 4, 3, 1, 4. Define a vector and print x. This is equivalent to just type x and press enter. Length of x, number of elements in x, 5. Note that our commands are written in a chunk which begins with the 3 back ticks and end with the 3 back ticks. The command rvec1 specifies that the chunk is for our language and is labeled by vec1. All the commands are to be written inside the chunk. Arithmetic operators. There are 5 basic arithmetic operators, and they are plus for addition, minus for negation, star for multiplication, slash for division, and this is for exponentiation, which are meant for addition, negation, multiplication, and exponentiation respectively. Besides these basic operators, a large number of functions are also available for arithmetic computations. Let us create a new chunk. Sum of x squared, then square root of x, log of x with base e, and log of x with base 10. Log of x with base 2. Then inverse of x, this is equivalent to x raised power minus 1. And sine of x, cos of x, then mean of x, variance of x, SD of x, and then suppose we want to compute CV, coefficient of variation. We need to define a function for it. CV is equal to function keyword x, then SD of x divided by mean of x into 100. We can dump this object in the file cv.txt, and we can source that cv.txt, then cv of x. Concept of recycling rule. The basic rule is that smaller vector recycles up to the length of the larger vector. Let us see the commands in the following chunk. X is equal to this length of x is 5. X plus 1. 1 will recycle up to the length of x and adds 2 raised power x. Here 2 will recycle up to the length of this and then it will multiply it with each component. Log of x plus 1 sine 2x. Naming an object in R. Some examples of valid and invalid names are given below. A1 is a valid name. 1A is not valid as it starts with a numeric. Star A is not valid as it begins with the special character. A dot is not valid as it involves a special character. A12 underscore 5 is valid. Atma Ram is valid, but Atma space Ram is not a valid name as fractured names are not allowed. Atma Ram is equal to 5 is valid. Atma space Ram is equal to 5 is not valid. The functions seek and rip. The function seek is needed to generate sequences. The operator, this colon operator is used to generate sequence with an increment of 1. Let us see some R commands. X is equal to 1 is to 30. So here 1, it starts with 1, 1 plus 2, 1 plus 1, 2, 2 plus 1, 3, like that. So it will go up to 30. It works backward also. So 30 minus 129 like this. X1 is equal to 6, from is equal to 1, 2 is equal to 30, and by is equal to 1. We can have 6 from 30 to 1. 6 from is equal to 1, 2 is equal to 10, by is equal to 0.5. So it will have a jump of 0.5. 6 length of 20. So it will make minus 5 to plus 5, 20 partitions. The function rip C1 to here 1 has to be repeated 3 times and 2 has to also be repeated 3 times. So this one will be the result. The rip C1 to each is equal to 3. So here each is equal to 3. Rip C R1, R2, R3, C 3, 3, 3. So here R1, R2, R3. Logical operators. True means 1 and false means 0. So there are other logical operators like greater than, less than or equal to, greater than or equal to, exactly equal to, and not equal to. So x is equal to C, x greater than 3. So those who will satisfy, they will be true, otherwise false. Like x greater than 2, 2 will not satisfy, so it will be false. This satisfies, so it will be true. This does not satisfy, false, false, true. Sum of x greater than 3. So here it will be 2 because there are 2 truths. X greater than 2. So it will select those who will satisfy this condition. Mean of x greater than 2. Mean of x less than 3. Mean of x such that x is less than 3. Mean of x less than 3. Logical expressions are, and. X is greater than 2 and x is less than 4, so it is 3. Missing values NA is dot NA. So here corresponding this, it will be true, the rest will be false. Mean of x NA dot RM is equal to true. Otherwise here mean was NA because of this NA. And then not NA, so true, 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 false. Mean of is not NA, 4. not a number, and 0 by 0 or infinity minus infinity, infinity by infinity. So x 0 by 0 is not a number, 5 by 5 1, and 3 by 3 1. Is dot na, so it is true. Character vector, they are always in the double quotes. X is equal to this thing. Names, these are the character vector. Character vector always treated in double quotes. Names of x is equal to Azam, Zulekha, Ankit. So x is equal to, these are the values and these are the names. Bar plot of x. So these are the bar plots. Paste. The function paste behaves like C, but it always returns a character vector. Paste Azam, it will paste Azam to 2, Zulekha 5. So paste is equal to double quote. So this will be the printout. Here it is. It has this operator between, and there is a space. Paste 0. So this space will be removed. Date of birth DOP. Then paste names, date of birth. So these are the paste name, date of birth. Paste 0, date of birth. Letters, letters, small letters, capital letters, and then letters C 3 5. So third letter and fifth letter will be extracted. Letter 1 is to 4. So A, B, C, D, 1 is to 4. Month dot ABB, abbreviated month, and month dot ABB, C, third and ninth month. Month dot name, this is the full month names. String, substring month dot name 1 is to 3. So first starting letter is 1 and third up to third letter. So January, February, like this. Factor vector, factor order. हाँ? असल में कोई है नहीं है, कोई कोई है, हाँ? इस पे क्लिक करो, ये जो ये है, कोई नहीं है, कोई है ना? हाँ? हाँ, ये वीडियो रिकॉर्ड हो रहा होगा. अच्छा, factor and ordered factor. Factor is the concept of factor in design of experiment. Factor talks with labels. For example, GRP, control, treatment. So GRP, these are the character vector. But when we will FGRP, these are the using factor, we will convert this vector into a factor vector. Now, these double quotes have been dropped, and these are the labels, control and treatment. As dot integer, control is 1 and treatment is 2. 1 to 1. Labels. Table, FGRP, these are the 2 treatments and 2. Plot, GRP, plot will give the bar plot. Labels, GRPC, treatment and control. So now this will have a different plot. See, treatment becomes first and control becomes second. Print, then xm is equal to factor x, labels is equal to c 1 2 3 1 2, and labels are male and female. So it will generate 1 for male and 2 for female. Table, male 6, female 5. XF factor C12, label female, male. So here it will be female for 1 and 2 for male. Insect spray. As dot integer insect spray. So we are selecting this. Matrices array and matrix array. Matrix and array. The function matrix is used to create a matrix. M is equal to matrix, 1 is to 6, these are the elements, and row is equal to 2, and col is equal to 3. So these are the column orders, 1, 2, 3, 4, 5, 6. Dimension of M, 2 dimension, 2 by 3. Dime names, M, list, letters 1 is to 2, and letters 1 is to 3. So here, these are the capital letters, and these are the small letters. Call names M, C, these are the column names. Samath, Radha, Umar. Row names Muradabad, Aligarh. Matrix. Matrix operations in R. X is equal to matrix. Now B is equal to another matrix. Now A plus B adds, this is the matrix addition. A minus B, this is again matrix negation. And this is the element wise matrix multiplication. And this is the matrix multiplication in column order. Trace transpose of A, T of A, transpose of A, and solve inverse of A. And solve into A is equal to into A. Solve of A, inverse of A into A, so it will be an identity matrix. If AX is equal to B, this implies that AX is equal to AX inverse B. So B is equal to this thing, solve A comma B X. Then function C bind and R bind, X is equal to C 2 5, X2 is equal to 4 3. Now CX1 2 is equal to C bind, column wise binding, X1 and X2, X1 and X2. RX1 2, R bind, X1 and X2, row wise binding. Determinant of A and diag of A, diagonal elements. Diag C, it will generate diagonal elements here. Diag 4 is an integer, it will generate an identity matrix of order 4. Cross product AB, this is the cross product, sir. This is A transpose B. Cross product A, this is A transpose A. V is equal to eigen A, eigenvalues and eigenvectors. So these are the eigen V values. These are the eigenvalues and these are the eigenvectors. V values, we have selected only eigenvalues. We have selected only eigenvectors. SVD decomposition, SVD A, D, dollar. D, this is the diagonal element. This is U and this is V. QR decomposition. Extraction from a matrix. Extraction from a matrix. This is the extraction operator. This square bracket is extraction operator. And before comma means we are selecting rows. After comma means we are selecting columns. And if we are having both 1 comma 3, so that means it is single element. We are selecting first row and third column. But if we are selecting M, comma, so before comma means all rows have been selected, whereas column 1 and 2. Similarly, all rows 1 and 2 have been selected, but the column 3 only. Arrays, A1 is equal to array. So this is 1 is to 8. C, rows are 2, column are 2, and third dimension is also 2. Dime names, the first dime name is AB. This is row names. Later 3 is to 4. This is second column, second dimension. And C, D1, D2. This is the third dimension. This is D1 and D2. Data frame. These are objects, a kind of generation of matrices, generalization of matrices, generalization in the sense that columns can be of different types from each other. This flexibility is not with the matrices. Use data.frame to construct a data frame from vector, colors, numbers, more numbers, color numbers. So it is data.frame colors, colors, colors is equal to colors, number is equal to number, and more number is equal to more number. So these are the three columns. This column is characteristic and these two are memory. Names, color, numbers. So we are going to change these names and these are the new names. Row names. So paste row 1 is to 3. So row 1, row 2, row 3. Similarly, color numbers, color number C1 and 3. So this is row 1 and row 3 have been extracted. DF2 colors number C1 3, one column 1 and column 3. Import and export. Reading from Excel. MS Excel is a very popular spreadsheet software for entering data. Most of the users come with the data entered into Excel and want data analysis done in R. Following steps are required. Enter your data into Excel spreadsheet. Save the data as comma delimited d1.csv. Read it into R. D1 is equal to read.csv, and in the double quotes you give the file name d1.csv. Save it into R. Write.csv. D1 file is equal to d2.csv. Row.name is equal to false. So these are the results. D2 is equal to read.csv. Similarly, d2.csv. Summary D2. So these are the summary. R has very powerful interface with other systems. One can import data from other packages by using the package foreign. Similarly, one can save output to the systems too by using the write.foreign. A set of commands are given. Library foreign data file is equal to temp file, code file is equal to temp file, write.foreign these data file, and then code file is equal to package SPSS. Reading data from SPSS, SAV system file. This is a system file available with the package electric.csv. Package equal to foreign, and then read.spss file is equal to SAV structure of dat. So this is the structure, and to make it as the form of data frame, read.spss 2.data.frame is equal to true. So it will convert this data into a data frame. Tails data frame. Reading from stata, one can read and a stata file into R, and illustration is made with the Swiss data available with the package data sets. The functions are read.dta and write.dta. Head Swiss, the structure Swiss required for a write.dta Swiss file is equal to Swiss 2.dta. Now Swiss 2 is equal to read.dta Swiss.dta head. Reading a data from internet. So suppose your data is available on this path, so you have to read.csv and give the path, you will get the data. So these are the some data sets. Then lecture 3, W3. Defining new function, name of the function, function argument 1, argument 2, etc. And then expression. Example 1, define a function for coefficient of variation, CV. Coefficient of variation is defined as percentage of SD, that of mean, that is SD by mean into 100. So we will define CV is equal to function of x, SD of x divided by mean of x into 100. Dump this, source this, and create height and CV. So this will give the result. Similarly, for defining standard error of mean, it is SD by square root of n. So SEM is equal to function of x, SD divided by SQRT, length of x. Dump SEM file is equal to sem.txt and source and then SEM. Trees girth. Descriptive statistics of a data vector, the function is describe. Describe is equal to function of x. X is a data vector. Xn is equal to length of x. M is equal to mean of x. S is equal to SD of x. SEM is equal to S by square root of n. CV is equal to S by M into 100. Range of x and quantile x prob is equal to 0.25, 0.5 and 0.75. Out is equal to list, and this will generate the list mean. SD, SEM, CV, number of observations, range, and then quantile. Out is equal to describe height, out one mean. Suppose you define a new function of weight as weight and need to compute descriptive statistics using describe. So define weight, describe weight, and you will get the result. Describe x is equal to height, so you will get height. Describe trees volume, so it will extract trees data from volume from the trees data, and it will give the summary of volume. Define, describe, which can handle missing values, na dot omit. So here x is equal to na dot omit x. This is to omit the missing values. N is equal to length of x, m is equal to mean of x, etc. So this will give the result. Extend the function describe for data frame, height, weight, then height, weight is the data which is data frame. So it has rows and columns. Describe D of data frame, function of x is equal to data dot frame, n is equal to n row, number of rows, m is equal to apply x to mean. X means this is the data frame and 2 means column. It will apply on columns, 1 for rows and 2 for columns, and means. So it will compute means. Similarly, S is equal to apply x comma 2 comma SD. So it will apply on columns of x for SD. Then CV is equal to S by square root of n, m by s by m into 100 CV, and SCM s by square root of n, out is equal to data dot frame, mean is equal to m, SD is equal to s, CV is equal to CV, SCM is equal to SC, round, return out. So data, we have to dump the data and we can source them. Then we can add minimum and maximum. So min, apply x min and max, and we can modify the definition. Built-in graphic functions, hist, plot, curve, histogram. X is equal to hist x, prob is equal to true. So this will give the histogram. Plot, plotting character with colors. So plot x is equal to 1 is to 20, y is equal to 1 is to 20, plotting character 1 is to 20, color is equal to 1 is to 20, and CEX is equal to 1. So these are the x into x is equal to 1 is to 20, y is equal to 1 is to 20, and these are the plotting characters, number 1, number 2, number 3, number 4, up to 20 plotting characters. And this is because of character expansion, 1.5 times larger than the normal size. Scatter plot, x is equal to sequence, y is equal to x raised power 2 minus 10 into x, plot y comma x. So this is the scatter plot. Curve from function curve, x raised power 2 from is equal to 2, 2 is equal to 2. So this is the curve. Then sine curve from is equal to 0, 2 is equal to 6 pi. So it is 0 to 6 pi. It is giving curve d norm x from is equal to minus 3, 2 is equal to 3. So it gives normal curve. Plot for a new function. Suppose you want to plot a function which is not defined in R. Say f1 is equal to function of x, and this function we want to define a function f1 x is equal to 2x plus 3x square from minus 3 to plus 3. So this is the function, and curve f1 from is equal to minus 3 to is equal to plus 3, color is equal to blue. So this is the function. This is the function. Then histogram, frequency curve, polygon ogive for a data. Where data is there, dump, and then length of weight 30, and then h1 is equal to hist, weight, hist, h1. H1 has breaks, counts in each category, then density, these are the density values, these are the middle values, and these are the x names, weight, and then equidistant true, and then class histogram. B1 breaks, lines H1 mids on x-axis, H1 counts on y-axis, type is equal to O. So this will generate this plot. And then we are going to add plot H1 miss cum sum counts, type is equal to A. So these are the plots. Cum sum, cumulative sum. And these are the stem and leaf plot. And pie chart, these are the pie charts. Graphics with R, there are two type of graphics functions. One is high level graphic function, and one is high level graphic function which always creates a new plot, function plot, hist, bar plot, dot chart, pie, curve. Second, low level graphic functions, they add on existing plot. For example, lines, points, mtext, main, sub figure. This is the data. This is the data, VA deaths, and bar plot, VA deaths. Beside is equal to true, and legend is equal to true. Y lim C090, and X lab death per thousand, main title. These are the deaths in Virginia. Dot chart is a function. VA deaths, X lim main. So this is the dot chart. Pie chart, these are the pie charts. Then histogram, hist, R norm, this is the data, mean, histogram, hist, and then we want to add a curve, D norm, mean is equal to 0, SD is equal to 1, add is equal to 2, LWD is equal to 2 for making it thicker. X is equal to REXP, mean is equal to REXP, histogram XE, prob is equal to true, and curve DEXP, the rate is equal to 0.06, add is equal to 2. So these are the, similarly, this is for Weibull, R norm, Weibull, box plot. are viable. Scale is equal to 50. Shape is equal to 1.5. Haste y prob is equal to true. This is the histogram. Box plot y horizontal is equal to true. So this is the box plot of the data. And then quantile prob is equal to this thing. Minimum, maximum, IQR. Lower whisker is equal to max of mean of y, and then first quantile 20.449 minus 1.5 into IQR y. So this is lower whisker, and similarly for upper whisker, min of max of y, and then Q3 plus 1.5 into IQR y. Box plot for iris data, names iris. So it is sepal dot length, sepal dot width, petal dot length, petal dot width, species. So this is the box plot of. Then scatter plot. So this is plot xy, Poisson versus normal. This is type is equal to L. So these are the lines. Type is equal to data, orange, names orange, tail, unique as that character. QQ plot, Z is equal to R norm 1000, B is equal to 0, SD is quantiles. So par MF row is equal to C1 to 4, 1 row and 4 columns. X R norm, A R norm 1000. QQXA main. So this is normal quantile and these are also normal quantile. But here it is rescaled. B is equal to R, B is equal to R norm, mean is equal to 3, SD is equal to 2. Then QQ plot X and B. So B is rescaled to X. B is rescaled to X. Here X is equal to 3. And here C is equal to RT with degree of freedom 2. So this is on y-axis, it is C. C has heavier tail as compared to this one is not. So we are adding a low level graphic function. These are the low level graphic functions. Adding to plots. Points, add to plot. Lines, add a line. Text, to add a text. Line, to add a line, y is equal to a plus bx. Line, h is equal to y, to add a horizontal line. Line, y is equal to v is equal to x, adds a vertical line. Polygon xy adds a closed and possibly filled polygons. Arrows x naught, y naught to x1, y1 draws arrows. Symbol xy draws circles, squares, thermometers, etc. Legend xy legend draws legend. Box plot with some additional features. Brand 1, brand 2, brand 3, brand 4, brand 5. Box plot, title, M text. These are the text, and side is equal to 3 and line is equal to 0. Line is equal to 0. X title, side is equal to 2, lash is equal to 2. Size is equal to 2, lash is equal to 2. This is the vertical. And then axis side is equal to 1. This is the first side. Add 1 to 5, 1, 2, 3, 5. Label names, motors. So brand 1, brand 2, brand 3, brand 4. So this way we can generate the graphs. These are the references. Is there any question from the audience? Is there any question from the audience? Do you need any clarification? कहाँ करना होता है सेव